Hi, this is your first note-taking session at home. Section 1.2, Points, Lines, and Planes. Our goal is to understand and use the basic undefined terms and defined terms of geometry and sketch intersections of lines and planes. A point has no dimension. It indicates a location. It has no actual size. So a point can look like this. And we would just name this point A. You would just call it point A. A line extends in one dimension. It's just long. It represents a straight path that extends in two opposite directions without end. It has no thickness. A line contains infinitely many points. So a line can be named by any 2 points on the line. Doesn't matter how many are on the line. If this is point A, point B, point C, then we can call this line AB, or we could call it line AC, or we could even call it line BC. Any 2 points on a line can name the line. A plane extends in 2 dimensions. It's long and it's got length and it's got width. And a plane is actually made of intersecting lines. It's represented by a flat surface that extends without end. It has no thickness. A plane contains infinitely many lines. You can name a plane by a capital letter that's indicated in the corner of it sometimes, like this could be plane P, or you can name it by any 3 points that are in this plane. So if you have point A, point B, and point C, I could name this plane ABC. Collinear points are points that are together on the same line. Like A, B, C are collinear. Point D is not on the line, so it's not collinear. The word collinear has the word line in it. Co, together, on a line. Coplanar are points that are in the same plane, that exist in the same plane. All of these points are coplanar. If I have another point that lays off this plane, point X, X is not coplanar with A, B, C, and D. On a line that passes through points A and points B, this segment that's between points A and points B has the end points A and B. This is called a line segment, and you just name it like this, segment AB. We can have a line segment that's just a piece of a line, like this one, DE. And I would just name this segment DE. A ray is a part of a line that consists of one endpoint and goes infinitely in another direction through another point. So this one I could call ray A, B, and you name it with just a tiny little ray above it, A, B. A is the end point, so A is here at this point. If I had a ray that went in this other direction, a ray has one end point, and it was like this, I would name this one ray BA. You always put the end first when you're naming a ray. The end is called the initial point. Opposite rays are two rays that share an endpoint and form a straight line. So in this situation, if I have this ray, CA, and this ray, CB, I have two rays, ray CA and ray CB. They are opposite rays because they have the same initial point. And they all together form a line. You can name this line AB, line AC, line CB, line BC, line BA. Lines can be named forward and backwards. Rays have to be named with their initial point first. Two or more geometric figures intersect if they have one or more points in common. The intersection of the figures is the set of points the figures have in common. Two lines intersect at a point. Two planes intersect at a line. So their intersection is here, like a wall and a ceiling meet, or where two walls meet in a corner. That's like two planes meeting at a line. Let's do this example together. Draw three non-collinear points, A, B, and C, meaning not together on the same line. Every 2 points have a straight line between them. The third point would be non-collinear. So now let's draw point D on line AB between points A and B. So let's construct line AB and put point D between them. Now let's draw segment CD. Segment has two endpoints. It ends at C and it ends at D. It doesn't go past them. It ends there. Now let's construct ray CA, meaning it'll have an endpoint at C and it'll go infinitely through A. And lastly, let's construct ray CB. So you begin at C and you go infinitely through B. So let's examine what we've done. We put 3 non-collinear points, A, B, and C. We put point D between A and B on line AB. Then we drew segment CD. And we drew ray CA and ray CB. Are points A, B, and D collinear together on the same line? Yes, they are. Are points B, C, and D collinear together on the same line? Are B, C, and D collinear together on the same line? No, they're not. They are non-collinear, B, C, and D. Now let's look. Are ray CA and ray CB opposite rays? They have the same initial point at C, But do they form a straight line? No, they're not opposite rays. How about ray DA and ray DB? Are they opposite rays? Yes, they have the same initial point and they form a straight line. So yes, they are opposite rays. Now you try one. Draw collinear points A, B, and C with point B between A and C. So A, B, and C. They are collinear, so B is between A and C. Now let's draw a point D not on line AC. And we're going to put point E on line AD. Point E on line AD. Between points A and D. Then we're going to draw a segment EC. Now remember what a segment is. A segment has two endpoints. So you want to end at E and extend through C, ending at C. Now let's draw ray BD. So if it's ray BD, that means B is our initial point and it extends infinitely through D. And lastly, let's draw ray EB. Where are you going to begin? Point E. And you want to go infinitely through B. So we have lines, segments, and rays in our drawing. So let's take a look at this picture to the right. You want to name these figures. 3 non-collinear points. Non-collinear means not together on the same line. So you could say points A, B, D. Every 2 points will be collinear. It's the third one that makes them non-collinear. Another example would be ADC or BCD. Let's name 2 opposite rays. Opposite rays have the same initial point and they form a straight line like these rays. Ray BA and ray BC. And remember, you name a ray with like a mini ray above it. BA and ray BC. Now let's name one line segment. A line segment has 2 end points and it's a piece of a line. We have several line segments here. For example, segment AD. And I would name this way, segment AD. Or you could even call it segment DA. Name another one. You could have segment DB. Or another one, segment BC. Or another one, segment AB. Or another one, segment AC. Now let's name 2 rays which are not opposite rays. A ray has an end point and extends infinitely in the other direction. So for example, ray BD, ray BD. Name a ray that would be opposite of ray BD. There isn't one in this picture. One that is not opposite. So, how about this one? Ray BA, or even this one, ray BC. Those would work. And the last one, two line segments that are on the same line. So, a segment is a piece of a line. This is a line, line AB or line AC. So two line segments on that line. You could say segment AB and segment BC. You name a segment AB and segment BC. Or you could have called it segment BA, segment CB. It's got two endpoints. Really the only one that matters how you name it is a ray. The ray has to be named with its initial point first. In geometry, it's important that you're able to visualize and sketch figures. Nobody has to be a great artist, but everybody has to try. So let's try a couple of these. So example 2A. Sketch the figure described. Three lines that lie in the same plane. Now frequently you will see a plane represented by like a piece of paper. It doesn't have to be though, but it can be. Two of the lines do not intersect. Well, from algebra you know that two lines that don't intersect are called parallel lines. And remember from algebra, parallel lines, they're never going to intersect. They have the same slope. And in geometry, we represent that two lines are parallel by putting these arrows on them. Now we're going to sketch a third line that intersects with each of the other lines in a point. So, a third line. It doesn't have to be perpendicular to them, meaning opposite reciprocal slope. It can just kind of go through them. And it's going to intersect them each in a point. Because when two lines intersect, they cross at a point. So this is two lines in a plane that do not intersect, but are intersected by a third line. All three lines lie in this plane. And now let's do example B. Example B, two planes which do not intersect in a line which intersects each plane in a point. It's more difficult to draw this kind of a thing because it's three-dimensional. But if I have one plane and then another plane, and if I have a line that goes through them, each in a point, it'd be kind of like this. If you can imagine if you had two pieces of paper that did not touch and you drove a pencil straight down through them. We'll talk about this example more in class. That's tonight's homework. So you were to take the notes that we just went through, and tomorrow in class we're going to practice these things and do an activity. If you missed any of the notes, you can always rewind this and go back. And if you have any questions, please make a note of your questions in your notes. If it's something that you need help on right away, you can email me and I will try to get back to you, or we can talk about it tomorrow in class when we practice these concepts. Have a good night.